This is a bad code talk. I gave it previously at C++ Now. I had to cut a few slides. I didn't cut so many as I thought I would. So I think I have to speed up on a few topics. But in general, as we're already late, we'll just start. That's me. That's what I do. I organize meeting C++ and run the platform behind it. But the actual topic now is bad code. So my first question to you is that valid C++? If you think it's valid C++, raise your hand. Okay. So 2 people are right. Those are digraphs. And this pattern is known as the bearded lambda, and as it's just an empty C++11 lambda, basically. So not everything that looks like bad code must be bad code. That's the point which I'm trying to make here. But also, you know, we had the experience in the spring that innocent-looking lines can be quite fatal, and so we had this go-to-fail bug, and this pattern directly occurred twice. First, we laughed about Apple, and then Linux had the same problem. That should not have been happening, but it did. It's a bug, and a bug can result from bad code, but that doesn't mean necessarily that writing go-to-fail is bad code in the first place. Well, using goto is, you can have an opinion on that is actually bad code, but if you want to see, that's probably with error handling again, the classic way to use goto in some places where C is used. And just as we thought it wouldn't come worse, we had the worst bug probably in history, at least in my opinion. Heartbleed was just this spring also. So again, one single line in the wrong place, really yeah, being responsible for a lot of headache for a lot of people. So this bad code, maybe bad code is your own code, because you know, we all learn, and the code we've written for 10 years ago, or some of us have written 10 years ago, probably would today not be as clean, and you would have to refactor it. And there are also other options, like, you know, maybe the bad code is written by the person next to you, you don't know that. And there's a few other combinations. One of the worst, I think, is if it's your boss. Then you have, you know, some older code piece which is perfect, and you have to use it because it's a code piece of your boss, and he probably still thinks that it's perfect, and you cannot refactor because either some companies don't do refactoring. So I did that presentation in spring in my user group, and I know now one company who is doing the refactoring always then when there's a bug report, because they're internally forbidden to do refactoring. So they always hope for having a bug somewhere so they can refactor a part of their legacy code base. Yeah, you see, weeks of coding can save you hours of planning. Which brings me to what actually made me start to think about the whole topic. I also work as a trainer for C++. I've been various years in the industry as a freelancer, and as a freelancer you see all kind of code bases, and you're usually called in because something needs to be done quickly, or something needs to be done where they don't have the knowledge for. So your know-how is needed, and that makes you see a lot of code bases which are quite different, and not all of them were beautiful. So for me, this poor man is a person whose main concern is not C++. For those kind of category, C++ is just filling the role of a tool. And if it gets the job done, that's basically what they are willing to invest. And if their code is already getting the job done, even if it's maybe getting better or more performant, that doesn't matter so much for them, because maybe they can drink a coffee more if the code is slower. As I mentioned, it's just one category. Particular category. Scientists can be in that area. Also programmers from other programming languages. Also, I've made the experience that this poor man's C++, that the person itself is not poor. They're just not a C++ expert, but they're often experts in a different field. For example, scientists, physicists, chemists. For them, C++ is just a tool to calculate something. And all they want basically is the results, and C++ is the fastest and best tool in some cases, so they use it. And so, as I mentioned, that those people might be producing or writing bad code is not often, not even their own fault. It's just the way it is for them, and it works too. So a critical thing I've often seen, especially also as a freelancer, is that you have a certain solution being copied and pasted in a different solution, then mutated. And so in this pattern, old code can live very long, and you have kind of an evolution with dead code being, hopefully deleted, often just commented out for future use. And so this can end up in a very bad state at the end. So typical problems I found in this domain are poor design knowledge, mixing old techniques and C into C++, C with classes. One big problem, I think, are old C++ books that still people which come to the department then learn and read those books. And also, in my opinion, memory leaks are a big problem, and you have, of course, as a current clash, which we can see is this loops versus algorithms style, that there are some people who think that we should do everything with algorithms, and then there are some other people which are just used to their loops, and they will always stick to their loops, usually because they're just doing that for years. And it can be very hard to get some people to switch from loops to algorithms, for example. And but there's hope, as they're experts. They usually are willing to learn, and hence they can be educated. But a critical problem in that is that the workload often in the industry is such a high workload that often then reaching them can be really hard. And again, sometimes you find the attitude that it works, and why fix it if it ain't broken? Which brings me to the next part. I have a few examples of different cases of bad code now, and in the details, first I'd like to talk about memory leaks, which in my opinion are still a big problem. Then I will talk about something called layers of engineering, that's the name I gave it. Then a bit about class design, monster classes. I think most of those problems, most of us I think have already seen it at some time. Init patterns, and last but not least, I'd like to talk about money. So there's a certain overuse of new, especially by people coming from other languages, especially Java programmers, sometimes also C# programmers. The problem is also that if you have a memory leak through that, that's not always a showstopper. If you have a memory leak, your program still will run. And there is, of course, the possibility to address that with smart pointers or object hierarchies, like Qt is doing that. But also I think that writing new seems to give some people a satisfaction we don't understand as C++ programmers. So I have prepared a small code example to show how difficult it can be to deal with this problem for some people. This is an example taken from Qt. So we have an action which is called when some button is pressed. And the first approach is just to call new. And the first is this 0, actually should be a null pointer in the example. So that's basically the parent. So this is a free pointer which will be a memory leak after we leave the function and the dialog is executed. So then we can fix the memory leak and put this pointer there so that the main window now owns that dialog, and some people will not realize that they now have made a resource leak, because each time this function is called, this dialog will be created, and hence if that button is pressed 100 times on a day, we have 100 dialogues open, and that's a little problem probably then, especially if you're running on an embedded system or something. So this is the classic way to fix this, to just put the dialog itself on the stack, which has the advantage that with the stack and exceptions, etc., everything, it's guaranteed that it's cleaned up, and the parent will outlive the dialog usually, so that also the destructor then again handles the deletion of the dialog from the parent. The problem with this is when the parent does not outlive the dialog. If we would instantiate here not a dialog that is modal, then we would have to use new, and also then we would have to take a bit of a different approach. But also when the parent dies and the dialog is still running, we would possibly execute a delete on a pointer which is on the stack, which probably is not a good idea. So problem still parent delete. In practice that won't play a big role, but then you could address that by using delete later and using new. Then the dialog would be deleted later. Still, exception problem is not solved. You could address that. Qt itself does not use exceptions, so if you're just using Qt, that's almost fine. You could address that with a boost library called CppCon. You could just wrap it in a code exit block, and then delete later would be called once this action is finished. So memory leaks are quite easy to fix if you use smart pointers. But I'm not really a fan of using smart pointers. I think that RAI is a very good concept, which is sadly still not very known in some areas. I found out. Quite surprised that a lot of C++ programmers still not really understand what it is, and if you explain it, they often have a similar concept, or they just, it's weird. If I'm from Germany, maybe they have a German word for it. But the bigger problem for me is actually that if we carry over this pointer style, we have overusing pointers as a first problem, then we have overusing smart pointers, and as a lot of people have started using smart pointers before C++ 11, we have this shared pointer addiction, that for everything a shared pointer is basically in the program running, which is also for the performance not the best. So in general, you should, from my point of view, prefer the stack. If you have to have an allocation with new, use a smart pointer, and raw owning pointers you shouldn't use anymore. So short word on refactoring here. Introducing smart pointers into a legacy code base can be quite hard through interdependencies, so that you don't know. You always have to very, very carefully test if you introduce smart pointers which are not shared, if you don't destroy some dependencies which were there before through a deletion or something. And again, you have this problem that you get from a pointer overusage and a smart pointer overusage, which will fix your memory deletion problems, but also not really improve your code base, in my opinion, except that you have less memory leaks, which is a good thing. And I once had a rare case with delete that I couldn't get the delete in as a commit from an import program because the deletes were causing the program to slow down, and as it was just an import program, the management argued, well, if you're slower with the deletes, we just leave this deletes out. It was running for years without it, and it was more important for the client to be fast. Which brings me to layers of engineering. I've seen it especially in bigger projects in the industry, which run for several years, that you have several layers of code which are usually wrapped into each other, and it's not totally clear where the boundaries are. Typical for such code bases are that you find comments, that your certain code base place should not be touched, as they don't understand anymore how it works, and maybe it's just code to interact with a certain part of the hardware, etc. is often such a thing, so that they mark their critical code areas with comments that you shouldn't be refactoring that because that's a critical point, and if it works, why change it. So typical for this is rather adding a new layer than doing a proper refactoring, and also often those code bases are poorly documented, as who writes documentation anyways. Problems with that, in my opinion, are usually that new features in such environments are often more important than bug fixes, and bug fixes are more important than refactoring, and refactoring is more important than documentation, for what I've seen over the years. That's how some problems in the industry are handled. Again, my experience is mostly in Germany. I don't know if the Silicon Valley handles this differently. But in such environments, you often have this vicious circle that people are very busy with implementing new features and fixing the bugs which the old features now have. So as another example, I short a few words on class design. I think we all seen monster classes that classes over time grow with adding every time a new feature, no refactoring. So the classes grow, functions grow. You end up in what also is known as dependency hell. In some places you have a certain overusage of object orientation, and one thing I've saw this year in a code base is an example for interface versus implementation. So first, somebody started designing the interface, and we end up with two validate functions. The one takes an integer as an ID, and the other one just string, which is the field name in the database. And both times, the function will basically validate a parameter, which is in this application kind of important. And the implementation then does something very interesting. The copy-paste method is approached, and then the validation is only taken for the ID, because that's basically what they then use later in their code base. But every function that is, every parameter class that is actually existing returns true on the validate if you give it the field name. So if you as a new developer, or maybe also some old developer making the error to call the field name with a string, the object would always be valid. That's a little problem. So fix is quite easy. You need a function which will give you the name from the field ID from the name, and of course you also then need to fix your code base, and then that bug is fixed. Also, what I've also seen, there is a pattern in object orientation called non-virtual interfaces. I think it's for object orientation not the worst pattern, but I've seen it rarely in application code, and also I don't know a lot of frameworks which actually use it. For example, Qt is not using it, WXWidgets is not using it really. And on class design, of course, to mention shortly patterns. I think pattern is a good knowledge. I've seen it rarely used in application code. No, that's some of the slide. But important is that patterns, of course, need to be used correctly and also implemented correctly. Few words on monster classes and methods. The previous mentioned layering can be a cause that just new features get applied, refactoring is not properly done, and so classes just grow over time and become monsters. Same thing goes for monster methods and functions. Sometimes it's also the problem that a lot of switches occur, and hence the functions are very long because there are many cases to test for. And in general, I'd love to get a tool to see from an unknown code base how to get an overview how the median of method lengths in a line of code is. And as I presented at C++ now, I had such a tool mentioned, but I haven't seen the recording yet. And of course, in that case, refactoring helps again. So one particular thing which I also often seen is that this init pattern is applied, which I think is especially bad if you misuse it. There's a few good use cases where you can use it, but often I've seen it's used to call virtual functions for the initialization. The next problem often is that a valid object must call init after construction, but you can construct an invalid object without calling init. Example is the CppBADC SDK from Samsung from a few years ago. There is a mandatory function to call, which is construct in that case called. And yeah, I've also seen it in the industry used. In my opinion, the init pattern can be quite easily fixed. Avoid virtual function calls, especially for initialization of objects, and use constructors properly. If you can't force make functions or factories, make your constructors private, and don't forget the operators which also can construct objects, and spend a thought on the rule of 0 or 5 defaults, especially in C++11 then. And as the last example, what I found is especially one thing which some people don't really understand is that people use float for their money in applications, and they don't realize that they lose money through that. Or I often have heard the argument that it's that the plus and the negative errors will zero it out and then it's okay again. I don't know about that. And in my opinion, money should be a type. It's a classic value type for me. And yeah, as an example, you should or could store cents in 1,000 units and use unsigned long or something. It depends on the how much money you have to store in such a type. And yeah, in my opinion, it doesn't make sense. It makes you lose sense. And short again, back to patterns. There's a very good book on design patterns, which I hope everybody knows about it. And anti-patterns, there's also a book on anti-patterns. the opinions on that book are quite different. I have listed just a few known anti-patterns, and I think in C++ 11.14 we can say that new and delete is becoming more and more an anti-pattern. And there's always also an anti-pattern catalog online. And yeah, macros are evil, or how we've seen that in the keynote at C++ Now 2012. And yeah, more examples, probably at a code base near you, and yeah, maybe in your next job. If you currently have a good code base, the next job could be different. Which brings me to the actual part of the presentation, how to deal with bad code, and how you actually can handle this and improve that in your job. This first, of course, I think you should always try to fix bad code if you can, but not always that's the option. And also for me, as I thought about the promise, that bad code might be only a symptom. Maybe it's, I mean, of course it's also a problem, but it's also a symptom, and fixing it always is a good thing to do, but we have to ask ourselves, why does bad code exist, and why do we have so often the exposure to it, as especially like for me as a freelancer, because usually in every place I have seen good developers, so actually we should be able to have far less bad code in this world, which we actually should have, than we actually have. So how is that coming? And code refactoring, it's not always easy, and it's always not always possible. And I've seen a very good slide in spring at a conference. This was a keynote on refactoring, that you should argue for refactoring always with economics in your team, and not necessarily with technical terms which your management might not understand. But before we actually can fix bad code, we have to understand that we have to deal with the actual problem. And as I always said, refactoring or rewriting is not always an option, as the code base might be too big for that. And also new or unknown parts of the code base can be classified as potential bad code. So how to deal with those things. First and for all, very important there, we have today a lot of tools for static code analysis. So if you have a new job, or you're in a new project and you don't know the actual code base, then you should use those tools. CppCheck is a free tool which does fairly a job to give you a first overview. The Clang static analyzer is supposed to be a lot better, but it might also depend on your platform. There are commercial tools which will do a very good job for you too, which in my opinion you should use. It's not always possible to get them in all instances. They're not that cheap often. And often this will give you a first list of things to fix and actually to refactor in your code base. Also on that part to mention is Clang Modularize. It's a program, it's an instance of Clang which can go through your code base and change it into a more modern style automatically. So if you're having a new code base or you're trying to modernize your own code base, it can be very good to take a look at Clang Modularize. It's a very professional tool. And of course for documentation there is Doxygen and GraphViz, which can also do wonder for documenting a new and unknown code base. That, as I said, is the biggest problem which exists is if we cannot fix it because just of time issues, or maybe the code which we think is bad code is written by somebody else in the team, and so what to do then? First, I think we should, of course, try to not infect ourselves with it or our code base with it. So if you can contain it safely and try to fix it later, that would be first a very good approach. But of course, I think very much more important is prevention, that the code which is bad code or becomes bad code is not getting written. So in my opinion, education of your team and co-workers is very important, but much more important in my opinion is also to educate your management, because what I've seen in a lot of hierarchy is the problems which lead to bad code, which lead to code written under time pressure and then being not as good as it should, is often through management pressure. So in my opinion, when we really want to fix that problem, we have to educate not only the teams who actually write code, but also those people responsible, giving the workload to those teams. And I've already mentioned old C++ books, so you might want to update them now with C++11 being available on almost all compilers. And don't reinvent the wheel, use libraries. That's, I think, also an important point. There's a lot of places where the not invented here syndrome is very, very common. So libraries can save you a lot of time and improve your code quality. And while I'm at libraries, I think it's a good practice to develop in modules/libraries. I know modules are not quite here, and C++17 hopefully brings us at least some version. And I think that even application code should be written in library code. And this forces, for me at least, a thought on how to define an interface, and not just to write the code in the library and not in the library in the application. So we basically would move then from this model to this model, and suddenly we also have unit tests, which is another experience which I met. How many of you write unit tests for their own code? Okay. As a freelancer in the industry, I have seen it in about 40% of the places. So this approach makes your own code base much more testable, and will automatically lead, in my opinion, to force people to think about their interfaces and improve the code quality a little bit, and with education and proper training, probably a lot. Also, back to hierarchies, I think what I've seen in some places is that a typical thing is that we have a product manager and a project manager, and they talk to each other, and then the project manager often gives time frames for a certain problem to fix and a certain problem to implement, and this can be quite fatal. So I think that communication is one of, or lack of communication is one of the origins of bad code for me, in hierarchies, definitely. And yes, so there is a certain bad code culture which I've seen in some places. So it's not always the fault of the programmer. If you're under time pressure, we all know this. You will not write the good code or as good if you had time to think about it. And testing is not an industry standard. I have not seen it in most places I've been. There's a lot of places which think that they test, but their code or test coverage is not really good. And also what I want to criticize is that not all IDEs and tools which we have for C++ today produce good code, or also often don't really have a good integration with tests. So default projects, for example, are usually without tests. So again, back to this layer of engineerings, in this cycle, I had once a client which, from my offer, had testing separately to the software development, and they basically blocked that out and said, well, that's an effort we will not pay you. That's testing. This is something which we think is not needed. And then I didn't work with them. Yeah, as I mentioned, I think that there should be more tests written in C++. It's good if you do. And yeah, there's test libraries out there a lot. There's even, yeah, C++11 has brought a few new test libraries. One of them is Catch. And basically, yeah, you're free of choice. What kind of test library you want to use for C++ is definitely there and out there. And as I mentioned, I think there's a certain lack in IDEs that testing is not supported properly. Default projects often or don't include any tests. And in some places, those default projects are basically the root which is used for their projects. And also in books and tutorials, test coverage is often rather poor. And so, again, I think tests should be more common in the industry. At least in Germany. I don't know how this is in the US. Maybe in the US we're already a bit more into a better direction there. And also, you know, if you're working in a bad environment, think about changing your environment. If you can't change things, you maybe want to change before the things change you. Because, you know, the IT industry, if you're honest, is not very healthy. And at least I know through running a meeting C++ platform, there's a big need for engineers. So if you're in a bad environment, get out and get a new C++ job somewhere else. Because, you know, a hamster wheel can look like a carry ladder from the inside. And also, when we look at the bigger picture, we're moving towards newer standards. Not all code will be rewritten, as the code base for C++ is huge. And with newer standards, refactoring should occur more often. So the problem with bad code is not going to go away. We will have more code which we might want to rewrite in the future or write in a different style. We see that with C++ 14, we have a lot of new things. With C++ 17, we have concepts probably, hopefully, and then modules coming after this or with it even. So the whole problem of bad code will not be solved by C++ 11 because we don't stop the standardization. We go on and have better and newer things. So the problem will become in the future more urgent, I think. And also, C++ education, I think, is an important thing. There is, you should, of course, for yourself, never stop exchanging and learning C++. Fixing bad code does not prevent it, in my opinion. Education and reaching more people who write C++ could achieve this. And if you're looking for a method in your own team, training is nice. Trainings are but also expensive, and in my opinion, not that effective. One very effective way to improve your own code quality and to train your co-workers are code dojos. There is a website called cyberdojo.com where you can run your own dojos for free. And so also it's probably a bit easier to argue with the management if it does not cost anything. You just need maybe half a day for this in the week to do an internal training with code dojos. And I run several user groups, and we also have done that in the user group. It's also quite fun. So you probably get people to engage more easily than they would do with training. And yeah, of course, there are books. I mentioned books before, though. One book which I think is very good is API Design for C++ from Martin Reddy. I just think, let it circle. it has a very good overview. It's written in a general style of C++. It does not go too deep. It's probably for advanced C++ developers, so it's the wrong book, but for a lot of other C++ programmers, it could be a very, very good book because it covers a lot of area. It covers testing, it covers scripting, it covers API design. And so it's a very, very good book to refresh knowledge and to motivate people again, I think. Then also, I will speak tomorrow in the first talk about with John Korb at 9 o'clock about C++ user groups, and I think that also C++ user groups can have their share in getting bad code a bit less urgent than it is, because with that we could create local, or not we could, we actually are creating local C++ networks, which are then again serving the purpose of education, exchanging jobs, so bringing people from bad to good jobs, and exchange of knowledge. And of course, I think it's also important to find more C++ talents and to keep them in our community and not to lose them to other language communities. And so for me, it's a basic building block of the C++ community. Which in my opinion should seen as a global community, which should also be better and interconnected. So which brings me to my conclusions for this talk. My goals for this talk were first and for all make you think of a solution that fits your needs, because as a freelancer I've seen that a lot of environments are very, very different, so there's no global solution easily possible which will always help everywhere. Bad code, in my opinion, can mean a lot of things, and especially it often also depends on your viewpoint and on your knowledge. This loops versus algorithms is a good example for that point. As you know, loops are not bad per se. A lot of people write code which they think is good, but when you have a different, when you're more advanced, you see that loops also have a disadvantage, and you probably should use then algorithms. And of course, prefer library over application code. Dealing with bad code, just as a repeat, fix it if you can, don't spread it if you can't, contain if it need to, and of course, let tools help you, like static code analysis, Doxygen for documentation, and Clang Modernize can do a very good job on automatically refactoring your application code and your library code and improving your own code base. And Clang Modernize, for example, also fix Memoryleaks, etc. And as I mentioned, I think that fixing bad code also starts with prevention and fixing the problems which may be existing on your teams, communication, etc. And of course, I couldn't resist. I organized one conference, and this is also another conference, and I've been visiting quite some other conferences. So I think that the exchange with the community on conference and user groups also will enhance your own experience with C++. And yeah, that's the last point then from me. Be engaged in the community, share your knowledge, not only with your colleagues, but also with your friends, etc. And one point which Eric Niebler, which is sadly not at the conference, pointed out last year at his keynote at Meeting C++, that it's a good thing to commit code to open source projects once a year as a practice. And yeah, as C++ and C++11 and C++14 are now basically final, we move on to a better world, and so we should try to create a better world with those standards. And in my opinion, modern C++, which those both standards are based on, already prevents and fixes a lot of bad code which we had before. So, any questions?
You talked about C++ IDEs not having very good test support. did you try the C++ beta for ReSharper or the betas or alphas for CLion, which is the other JetBrains C++ IDE, which became available recently?
No, but I don't think that those IDEs are really fixing the problem, because I just don't think that they will spread in a way that, you know, I know Visual Studio has, if it's rightly done, good implementation for that. I'm using a lot Qt, so Qt Creator can be forced to do it, but it's not built in by default. And I know that there are newer IDEs which often have a better support, but I also know that a lot of people in the industry will take years to see any of those. So it's good that the newer IDEs catch up in that part, and I think it's a good sign. But it does not really solve the problem from people which are in the industry, which are still, you work for years on the same compiler. So Microsoft Visual Studio 2012 or 2010 or the 6er version, and the same also with Qt Creator. That some teams just they start with a version and they will never be upgrading quickly. So if you can upgrade your compiler, if you can upgrade or change your compiler to a better version, and your IDE, which brings you more than C++, C++11, etc., that's a very good thing to do. But in the industry, I doubt that a lot of people are able to do that, as this is often the decision from, again, a management decision, and that's also a point that it's very important to actually educate your management so that they understand why you now need to spend money or to have an effort to bring your project from one IDE to another to improve your own work and make it easier. But it's not always understood by the management.
And is the main crux there that you're, if I'm trying to understand you, is that in Visual Studio the IDE is coupled to the compiler version, and in the case of Qt Creator, like it generates code or parses your project files, and therefore like changing those is quite difficult as a result. But if you're using a decoupled IDE like Vim or Emacs or Eclipse CDT, for instance, and it's decoupled from your tool chain and decoupled from your code generators, is that a lower barrier then? Is the barrier that you're saying is because in Visual Studio and Qt Creator, like you're either bound to a compiler or a code generator that's kind of tightly integrated with the IDE, and therefore like it's not very versatile, and that makes it a harder sell, or even something that you would even have to convince anybody of?
Sometimes,
is that what
yes.
you were saying?
Sometimes, yes.
Okay.
You spoke a little bit about shared pointer addiction. Can you elaborate a little bit, and specifically, do you see problems with shared pointers other than performance?
The problem with shared pointer I see is that shared pointer is basically a new, which also will always allocate a little bit more. So yes, the biggest problem with shared pointer is performance, but also I think that and often in the cases in the code bases I've seen is, if you need shared pointer for sharing the pointer, then shared pointer is correct. And if you need shared pointer because you don't have a better access to a version, then shared pointer is also correct. But what I have seen is that people are not aware that they might be, maybe, should start using the stack instead of that. So for me, it's clear that if you're refactoring a code base, there are code bases which are very, very C orientated and which are not really have moved on into C++. And there often are a lot of pointers used, and then you replace those pointers with shared pointers, which are objects. So in my opinion, you fix maybe the memory leak problems, but you introduce much more problems which come from shared pointer if you overuse it. And in my opinion, yeah, it is just people need to understand that they should rarely use delete and rarely use new, and that they often should, be more on the stack and be more safe with the code they write. Yes?
I found that the question that goes along with that is that why the data needs to be shared anyway. Like how independent are your components? It makes threading harder, sharing data. It breaks value semantics, which is, there are raft of issues that go along with it. It's kind of a bad smell.
Yes. I agree. Any more questions? And thank you for coming and listening.